Hello. So today we are going to talk about pluggable authentication modules of Linux, which is commonly known as PAM. We will try to understand it with an example of faillock, which is used to lock user account after unsuccessful attempts. So normally you can go a very long time without having to tweak PAM, and in most cases you won't have to alter PAM, but sometimes if you need to uh, make your systems more robust, or if you are running third-party scans, and for compliance reasons you might want to strengthen or harden your system a little bit. So we will look at what PAM is, why it is used, and we will also see an example, and we'll try to understand how it works. So to start with, what is PAM? So if you see my screen, I have a file opened already. So PAM is basically um, it is a mechanism to call certain functions related to authentication. Um, what I mean by functions is basically libraries. So if you see on the right hand side, we have a list of libraries. Please ignore these two fields. I will speak about them more later. So we can see there are multiple library files which are being called from PAM module. You can see there is Linux, deny, Unix. We'll go through them briefly, but the end goal of PAM is to provide a means to authenticate a user or an application, and authentication can be very as simple as just verifying something, or it could be multiple things that need to work together to grant access. For example, if you want to grant access to something to your system, first thing you would expect is authentication, password authentication. Then you would also need some sort of an authorization if the user is permitted to do something, or what sort of access the user has. Or let's say you want to log something. Once the user logs in, you want to keep track of um, how many times the user has logged in, and there can be multiple things that you would want to do with authentication. And authentication is not limited to console login. If we are talking about Linux, if we log into Linux directly, we talk about console login. If we are using SSH, as I have done here with Putty, we are using a different sort of a mechanism to log in, because it uses a different terminal from console. Similarly, there are like multiple um applications that interact with authentication differently. So you might want to uh, handle them differently, and there are multiple stages to your authentication. You would first authenticate that you have the required credentials to access it. Then whether your password is matching, uh, and once you establish a connection, once you are into the session, then there are few other things that need to be figured out. So we will look into all of this. So now I'll come to the operating system. I'm running Alma Linux, which is similar to Red Hat and CentOS, and PAM is basically same in most systems wherever you are using it. So in Linux, PAM is mostly configured inside the directory called etc pam.d. So if you see, this directory has a lot of files. So what are these files? So each of these files is a different service. We can call it that. For example, I was talking about console login. So console login is mostly done via system auth. and I was talking about login via SSH that is handled by password auth. Then there are multiple things. For example, some service might be using login, and if you are using any remote protocol, then this service will be in use. And we can see similarly we have a service for sudo. So during the authentication, it is calling this library. So actually in PAM you can call a different service altogether. So if you see, sudo is calling system auth all the time. So any constraints, I'm sorry, just let me get some water. Yeah, so any constraints that you would apply on system auth will get applied to sudo. Basically, this is what it means. And the control directive we see here is include, which is used to include another module. So let's talk about what these services are. And, for example, we are going to take password auth because we are going to apply faillock on it. So PAM has a concept of stacks. What is a stack? So a stack is sort of a module that uh, uh, can fail or pass, and it we call it module because it is modular in nature. So the stack is made up of service plus um, this module that we are seeing here. So for example, the service that I'm using right now is password auth, and the module is auth. So password auth and auth together they make one stack. So if we notice these three lines make one stack inside password auth service. So this is one stack which is password auth / auth. We can call it that. Then second stack is password auth account. Third stack is password auth password. Fourth stack is password auth session. Um, Similarly, like you would see this in other files also. Let me open system auth. It also has very similar module list, but we cannot say that it is the same stack because uh, here auth is getting merged with password auth. So password auth plus auth makes one stack. So this stack is completely different. These two are not the same stacks. And this service is in use by SSH, and this one is being used by other methods that are used to authenticate to the system. So yeah, so this is how we refer to stacks. The service and the module make up a stack, and each stack is modular in the sense there is a verdict for each stack. It either passes or fails, and if it passes, we move on to the next uh, stack, or if it fails, uh, there is a little bit of vagueness actually. So if it fails, let's say if one stack fails, and it happens in sequence, uh, if one stack passes, then obviously the control will move on to next uh, stack. But if there is a failure in the first stack, it is not guaranteed that the control flow will stop there or it will go ahead, and even within the stack it is not guaranteed. So we'll come to it later. So for now we can understand that there are several services that make use of certain login libraries, and this PAM is sort of an orchestration as to where to call certain libraries, right? And let me try to see if I can list down uh, things that are being called by SSH. So if you see, we are calling libpam, right? So we are using uh, PAM module with SSH. Um, Let me see if I can check everything that is open. I cannot. Okay, I do not have a list of. Let's try to figure out if we can see uh, uh, that library link to our SSH process. If we can see it, that would make it much clearer. For now, we can see that this binary is linked to PAM, so it is using PAM. Alright, we have ls of now. Okay, so we got a list of everything that was called by this service. Alright, for now I'm not able to see exactly. Maybe I can update on it later. So the idea is that when SSH authenticates a user, it makes use of PAM, and then it calls all those libraries that are defined, the configuration. I'm trying to think of a way to see whether we can show any linkages. Do we have a service for SSHD? Yes, we have. So yeah, I think we can see it here. Okay, we are including post login, right? For if you see for the account, we are making use of password auth. So we can see that for SSH login, we are making use of password auth. I think similarly this would be for login also, if I remember correctly. Right. So if you see login is system auth, which is console. So if I need to log into Linux console, say via VMware or my uh, on-prem server, if I'm opening the actual terminal, then this login module will get called because I'm making a login, and this is later on including system auth. So any change that I make to system auth will get applied here, and any change I made to password auth will get applied for SSHD. I hope it's clear. I don't quite remember if I can show any linkages directly with the uh, service, but yeah, I think this should give us some idea about how this is getting called. So for uh, for our SSHD to authenticate and work, it has to pass this stack, which is an account stack, and at the end we have password auth, and it should also pass this stack. So it should pass both stack, and if you notice, authentication also is a substack of password auth, so it is also including password auth for authentication. So until our password auth passes, SSH login will not be granted. So this is basically the flow for PAM. SSH is using PAM, and it is dependent on password auth. And any restriction you want to add, we can add to password auth for locking any access. So now let me go to configuration. So this is how basic configuration looks like. So here we have opened the configuration for password auth service, which is used by SSH, and it has 1, 2, 3, 4 stacks. And for this service to pass, all of these tags have to pass. Now let me come to the control flags that we are seeing. So when I said earlier that the control flag, the control flow is a bit vague, it is because of the control statements. So first statement that we are seeing is required. So required, as its name suggests, it is required. So if let's say this line fails, I will come to what that means to have have a, have this line fail. So if this fails, we are definitely going to suffer a failure of our stack. But required doesn't stop us from processing further. So that is the caveat of required. So even if my required fails, I can move forward, but my stack will still fail, right? The stack will still fail, but my uh, control will move forward, right? And at what point control will stop here? Required fails, let's say this required fails, it will keep on executing. It will execute sufficient, required, required. It will stop at requisite, and we'll talk about it later, right? And let's say there is this whole service and stack list ends here. Let's say this file is limited to these 4 lines. Then the execution will continue till the end, right? So this is the idea behind required. So required doesn't stop the flow. Basically, that is rule number 1 of required. Rule number 2 is it is required, as its name suggests. Otherwise, our stack will fail. So that we have to remember. Second flag we are seeing is sufficient. So it is also based on its name. It is sufficient, but it also has a caveat, and that is it depends on things that have happened before it. So sufficient is sufficient only and only if everything above it has passed. So let's say our this first line, our required line, has failed. Then the sufficient will not be of any effect. It will not do anything. So it passes, fails, it doesn't matter. And if required has passed, then there is a completely different story. Then sufficient will sort of veto everything, and nothing below it will be able to execute. So we discussed 2 rules for required, right? It doesn't tweak, our control flow, but it is required. On the other hand, sufficient tweaks control flow, right? But that tweaking is conditional, and it is sufficient, but that is also a bit conditional. So sufficient can be seen primarily as a very vague conditional sort of a operator. For it, it depends a lot on what has happened before. So if everything above it is successful, then it will change your control flow so that this line will not get executed and it will be sufficient. So it is very simple to understand what it is doing. But let's say something failed above it, then it will not do anything to your control flow. Then it will simply let everything pass beneath it. And uh, The other thing is that it will uh, not be sufficient anymore, right? So that is one thing that we have to understand about sufficient. So it is a bit vague. Then coming to requisite, so one thing we have to understand about requisite is it is similar to required, except rule number one, that it changes your control flow, and requisite is sort of has this vetoing power that if it fails, nothing below it gets executed. So if you are seeing this stack has three statements, let's say requisite fails, then nothing below it uh, gets run, correct? So that's the power of requisite, and it differs from required in that sense. We see two more flags here. One is optional, and there is one more flag which we'll talk about. So optional is basically optional. So it passes, it fails, it doesn't really matter. It is basically used to call something on the side. Let's say you want to log something. I don't really know what key init revoke does, uh, and PAM system D. So it is basically used to call libraries that are not really, you know, that important, whether they pass or they fail, but it is important that they run. So this is optional. So even if a line which has an optional fails, nothing happens, or if it passes also nothing happens. So then this is optional. Finally, let's talk about success one. So success one, since these are control statements, we can you can see a lot of things inside square brackets in PAM, and one of the common ones that you will notice is there is success one and default. So basically, what default is telling us is that if this library results in success, then do this. We'll talk about what this is. For everything else, ignore it. Right? So for everything else, we are simply ignoring the status. Whatever, if this library fails, if it gives any sort of exit code, we are ignoring basically. But if it succeeds, then we run this. And what is this? Success equals to 1. Success equals to 1. This 1 is basically number of hops, and number of hops is the things that come beneath it. So success 1 means it will make one hop, and which basically means that it will not run this line below it, right? And let's say there is failure or something, anything else, this it gets ignored, but it jumps to uh, next line. But why, the question is like, why do we have this sort of control? And the answer is PAM Unix.so. So let's say there is success. Sorry, I think maybe I should uh, explain this better here. Yeah. So we have requisite, sufficient, required, requisite, sufficient, required. Okay, this is a better example. But yeah, let's go to this example because we want to go through success one. So this control line is basically saying that if it is successful, don't run this. It will get skipped. But if it is failing or something, then this module will get run. So basically that's a condition that if it is successful, all good. Otherwise, we need to pass this, right, for the stack to complete. And so this is a very simplistic view. Like PAM can be very challenging to understand. It can have convoluted control flow, but if we have these things in our mind, that service and module makes a stack, and stack is modular, it fails or passes, and its passing and failing is basically guided by the control flow that we control statements that we define here. And at the right side we have a library and the options. Right, let's talk about the options. What are the options here? So PAM Unix is getting used for authentication, and it is sufficient condition, and the options are that it tries first pass, and null is okay. Try first pass is basically any module that got executed before this, and if we have stored any password for it, then it will reuse that password. See, there is simply that flag. And null OK means that it is okay to provide a null password for any account, which is okay. You might see this as being not a very good security practice, and we can maybe actually remove it also to strengthen our system a bit, because we don't want people to log in without any password. Yeah, so similarly you will see there are a lot of options that we can provide to the library to change how it works, right? So how do we find out, like, where what these options are? What How should we configure it? Uh, for each library, like, there is a main page. You can open Google Chrome, and there is a website called uh, linux.i.net, which has a lot of main pages on various PAM modules, where you can see all the options that you can provide to the library. And you can also see how the control flags behave, what they do. But until unless you work on PAM, it will be tricky to understand, at least for beginners. So now I think now we have some understanding of what is happening, right? And now comes our tutorial, our example of uh, adding a fail lock. So I'm going to add a fail lock mechanism to SSH logins. For that, I need to alter password auth. Actually, password auth is used by multiple services like SSH, so that you would see this pop up in a lot of compliance scans if you're running them, because these password auth and system auth, they are used by other services. So these are basically system-wide settings that you apply to your system. So I'm going to make a change to password auth so that it gets applied on our SSH logins. And this change is for authentication basically. So we don't allow any authentication to happen if password failure has occurred few times for in a particular duration. So we will be applying this to authentication stack, auth stack. So for now, our auth stack looks like this. Very simple. First line is required, pam env.so, which simply loads the environment variables, nothing else. And we'll not be touching it for our tutorial, so we can sort of forget it. What we will be concerned about is these two lines, and we will try to understand PAM based on what we add to this stack, the lines that we add to this stack, and how the behavior changes of these two remaining lines. Next line in this stack is sufficient. Pam.so try first path null. Okay, basically checking the password. If it is correct, then this authentication stack is successful. Authentication is done. If we provide wrong password, this gets run. And this by default denies authentication. It is PAM deny, it denies authentication. Basically, this will mean that our stack will fail. We'll be denied authentication. Correct. So it is very simplistic. Correct password, login. Incorrect password, will not be able to log in. This is how our stack is working right now. But we want to change it into, so that if, let's say, we are simply protecting against brute force attacks, right? We don't want people to just bombard us with lot of login requests and just brute force their way into our system. So we need some sort of mechanism to control that. So we are going to stop any user who has had 3 unsuccessful login attempts to gain access to our systems for a duration, right? So there are multiple man files that we can make use of. So but I will simply open my terminal, and I will be changing them based on Vim, using Vim. Okay, let me open this. Alright, so we are going to make change to our auth module. We are not going to touch PAM env. So The first thing that I will add is I will add another line here, which is authentication. I think I just deleted a line. Okay, it's fine. So I'm going to add one more line to authentication stack, and this line is going to be required. This is going to be required, and we are going to add faillock. So faillock is our library to give us this functionality of locking a user account, right? And we have marked as required. This is very simple as of now, right? If this fails, we will fail the stack, and stack will not be able to go through. But we have, if you notice, we have not added how we will come to the conclusion that the user account is logged, right? So if user account is not logged, this will always succeed and nothing is going to happen. So now we are going to add that logic into it so that our faillock is functional, right? So faillock has a lot of options, and one of them is pre-auth. Pre-auth is an option which allows us to apply things before authentication. So if you notice, we are doing main authentication here. We're checking our password, calling PAM Unix. So this has to be, pre-auth has to be called before we do any authentication stuff. So we are calling it before authenticating the user, correct? So it has to run before, and we have to check. What do we have to check? We have to check whether the user has had more than 3 failed attempts. We will come later like how we will log them, but for now just we need to concentrate that on checking. So this can be deny. This is another option. We are going to deny after 3 unsuccessful login attempts, and unlock time, let's say, let's make it 60 seconds because we need to run this tutorial, so they should be fast enough. So we are going to unlock the user account in 60. Normally would make this a bit higher, 10 minutes or 15 minutes. So this, just for the tutorial's purpose, I have done this. So basically our first line is done. So what we are doing here is we are just, before authentication, we are checking. What we are checking for, whether we have 3 failed attempts for this user during last 1 minute. If we have this will fail. Got it? And if this fails, since this is required, our stack will fail. Alright. So this is going to be our mechanism to deny access to the user to fail the stack. Correct. Now we will come to like defining now I'll define the second line. Alright. So other lines have to go beneath authentication, because pre-auth is done, authentication is done. Now we will add, I'm going to add another line. I'll add both line at once, then we can talk about it. Auth default die, and rest of the stuff is same, except the option will be auth fail. So using auth fail here with default die, if you remember early on we discussed that default is the default behavior. So this line simply means that if it runs, we are going to close the connection. That's all. If this runs, and when this runs, this when this runs, Okay, I'm going to come later to it because it will be a bit complicated to define it right now. Let me just complete all the changes. Then our third line is going to be auth sufficient, and it is again going to be, I'm going to call faillock again. So they are all doing different things. All right, other two will be the same. So we are just giving the state to all three options of faillock, and there is another change that we are going to make, and it is that we are going to change our PAM units from sufficient to success one, because we would want to skip it in one case. So actually this is it. This is the change that we would make to our module. So let me go through it one by one. So as I've already told you about that, pre-auth will fail if there are more than 3 unsuccessful login attempts. We are clear about that. Now we have changed PAM Unix from sufficient to authsuck. Sufficient to conditional. So as we have discussed earlier, it is very similar. Default is going to be failure. So if this module doesn't succeed, our stack is going to fail. We'll not be able to log in. Correct. Another thing is if it is failing, it will go to fail also, auth fail also, auth fail option, and auth fail will basically increment the fail log count. Right? We spoke earlier that we are going to check the uh, unsuccessful attempts, but where are we logging it? We are logging it here. I will talk more about the control flow because that is a bit complicated. But the thing that we need to understand here is what fail log is doing. Fail log is basically auth fail is basically incrementing the counter. That's all we need to understand. Because if there is an unsuccessful login attempt, then we are not going to skip this. So auth fail will only be skipped if authentication is successful. What this means is that we are not going to increment our failed log count. This is what it means. That is what we have to understand for now. Finally, our third line is this gets executed when success happens on PAM unit. So if you're catching this, if this runs auth success and it has some conditions, deny 3, unlock time 60. So if it is not beyond that, if unlock time is still uh, uh, greater than 60, then what it will do is it will reset our fail log count. So this is a sufficient condition provided 15 minutes have passed. If 15 minutes have not passed until this account is locked, this will fail. Okay, that you have to understand. And if like we have more than 3, and if even if we are giving it correct password, then also it will fail. So this is the reason we are giving it in each option, in each call to this library. Uh, so it will check for the duration, it will check for the number of failed attempts. But if let's say if the duration is beyond 60, if a long time has passed, then when authsuck is getting called, authsuck will reset the counter which is uh, incremented by auth failed. So if you notice, we are checking for the failure and failing the stack here with pre-auth, but we are actually doing the mathematics of this module in these two lines. We're basically incrementing failing the stack, and we are marking this as sufficient. I will come to the flow later on. So I think it's time I can move on to the flow. So what happens now given this flow? So PAM env, let's ignore this. So this is required. So when I open a SSH terminal and I try to log into my system, if I have previously in last 1 minute 3 unsuccessful attempts, this will fail. Alright, but since required doesn't stop anything, we will keep on going, right? It will keep on running these uh, other sorry this it will keep on running these other uh, modules, and it will increment, it will decrement on if I write wrong password again, faillock will run again, it will uh, append the counter, it will make it 4, right? And if I provide correct password, sufficient will run, but it will not be passing because unlock time is less than 60, and it will not be able to reset the clock. It will simply do nothing, right? It will simply pass through. Finally, since sufficient is not running, PAM deny will run and it will deny our authentication. So in a way, uh, we can maybe skip this also, this line. So, but yeah, I think this can be skipped. Uh, Pre-auth can be skipped, I think, because we can authenticate. Then if it's failing, it's successful. Yeah, I think this can be done, but it is better to check, right? We don't want any passing of uh, our account happening because of this. So authentication is basically this, and the behavior will be like this: sufficient condition. Once this is satisfied, unlock time is more than 60, we will be able to authenticate using our SSH module. So let's see it in action. Okay, so I have edited it. So as soon as we edited it, automatically takes effect since it is getting called dynamically. Let me open a duplicate session. So this is a user that I'm using. So this is okay. I have entered wrong password once. Let me try once. Okay, what okay, it is not allowing me access at all. What happened? Okay, I think I have misconfigured it. There should be a space here instead of. Sorry. I think we should be able to work through it now. Duplicate session. Okay. Did I log this user? Faillock. Yes, this user is actually logged because it is logged because of pre-authentication. 3 unsuccessful log attempts. And now the last time this happened was 8, 17, 11. So by now this should have been fixed. So let me try this once again. Set the password. Alright, I'm able to log in, and if you can see, it is telling me that there were 5 failed login attempts since my last successful login, and I'm able to log in now. And now if you see, this has been reset. So what is happening here? PAM and we were ignoring, let's say. Let me open it again. So we saw this in action, that we had multiple failed attempts. Even if it was because of misconfiguration, this got picked up, and pre-auth did not allow us to log in. It failed our login, but it ran PAM Unix, and it ran auth fail and it incremented. So instead of me seeing just 3, I saw 5. So all of my failed login attempts were getting executed because this is required. So it will fail the stack, but it will still run them, right? It will still run them. Auth will do nothing because account is locked, and PAM deny will finally deny access. So this is we saw with this, right? This is the counter I was talking about. It got we have 3 entries, but there were 2 more. But these were the original entries that blocked the access, correct? So after that we saw auth fail in action. We saw pre-auth in action also, but finally we saw auth successful in action. When we saw it after 60 minutes, I tried again and I entered a correct password. So let's see what happens when I enter a correct password. So we have this required, pre-auth and deny 3, unlock time 60. This time it doesn't fail because we have passed 60 minutes. This passes. Then you move into PAM Unix. I provide a correct password, it passes. It jumps on faillock. So there is no increment of this table. It jumps directly to auth successful, and auth is successful because pre-auth is successful. It marks the authentication as successful. We are beyond 60, so this is sufficient. PAM deny doesn't run. We are able to authenticate. So this is how faillock works, correct? So early on we did not have these 3 lines, faillock lines, and we did not. And instead of this PAM Unix being conditional, having a condition basically for faillock, that's all. Because otherwise it is same, like success marks the stack as successful, bad marks the stack as failed. So basically it is same as sufficient, but we have simply changed it so that if it is successful, auth fail doesn't run, which in essentially means that if we provide correct password, this table doesn't get incremented. Simply that. We have made only one change to panunix.so for auth stack. That is the one change. Other change is this. We have simply added faillock. And faillock is again very simple. Pre-auth is checking before authentication whether our account is logged. It won't give us access even if we provide correct password. If we provide correct password, our table doesn't get incremented. If we provide wrong password, our table gets incremented. Our table gets empty reset when we pass the time. Alright. So I hope this is clear and I was able to give you some sort of understanding of PAM. Similarly, we have tweaked a little bit with auth module and password auth service. Similarly, we can do other service also. There are multiple control flows, but this one is a bit common one that you might see. You might have to do it one day, and this I think also serves as a good example of simply the control flow. Like I have seen people struggle with it, so this I think gives us more better understanding of how things run, right? uh, and it also gives us a correct view of the sequence in how it is executed and what these control statements mean, what this means, and what are these options, and how do they work all together, right? uh, so if let's say if you are not aware of how PAM is, so this will look very similar to this and very similar to this. So on first look you will somehow feel like, okay, PAM env is required, PAM faillock is required, it is sufficient also, PAM deny. So it will not make much of sense because everything will look same, right? This line is very similar to PAM deny, right? There is not much difference. So it is almost it will look like both of these modules are being called in a similar way, right? Even faillock here is required. So but they are all doing something completely different, right? So this has some effect if based on this time, and it doesn't have effect if this time has passed. Then there is this very complicated control flow happening here. This always runs, this this is conditional. If it is sufficient is passing, this doesn't run. Similarly for auth fail, it doesn't run if this is passing. So control flow is very tricky to understand here. I hope that this was clear, and if you really like this, let me know. And I think this is all that I wanted to share. So thank you for watching. Goodbye.